This is the 2015 AP Physics2 free response question. Let us see what is the question. A battery of EMF E and negligible internal resistance, 3 identical incandescent light bulbs, and a switch S that is initially open are connected in the circuit shown above. The bulbs each have resistance R. Students make predictions about what happens to the brightness of the bulbs after the switch is closed. A. A student makes the following prediction about bulb 1. Bulb 1 will decrease in brightness when the switch is closed. First subbit. Do you agree or disagree with the student's prediction about bulb 1? Qualitatively explain your reasoning. 2. Before the switch is closed, the power expended by bulb 1 is P1. Derive an expression for the power P nu expended by bulb 1 after the switch is closed in terms of P1. Next bit. How does the result of your derivation in part A2 relate to your explanation in part A1? B bit. A student makes the following prediction about bulb 2. Bulb 2 will decrease in brightness after the switch is closed. Subbit. Do you agree or disagree with the student's prediction about bulb 2? Explain your reasoning in words. Justify your explanation with a calculation. C bit. While the switch is open, bulb 3 is replaced with an uncharged capacitor. The switch is then closed. Subbit. How does the brightness of bulb 1 compare to the brightness of bulb 2 immediately after the switch is closed? Justify your answer. Next bit. How does the brightness of bulb 1 compare to the brightness of the bulb 2 a long time after the switch is closed? Justify your answer. Here, a circuit is given to us consisting of 3 incandescent bulbs having the same resistance connected to the battery. E is the voltage of the battery and R is the resistance of each bulb. And then a switch is kept here at the next to the third bulb. Okay. The question is, when the switch is closed, bulb 1 will be brighter than bulb 2 or bulb 2 is brighter than bulb 1. That is A and B. Okay. A student makes a prediction that soon after closing the switch, bulb 1 will be brighter. Okay. No. Bulb 1 will be dimmer. That is the one student prediction. And then the second student predicts, soon after closing the switch, bulb 2 will be dimmer. Okay. That means decrease in brightness. That is another student's prediction. And the third one is, instead of bulb 3, if the bulb 3 is replaced with a capacitor, then what happens? This is the question, the gist of the question. Now we have to look into the technicalities of the circuit. This is a combination circuit. Initially, when the switch is open, this is a series circuit, just this one. 2 bulbs are in series. Both the bulbs have the same resistance connected to a battery having the voltage E. Okay. And if we close the switch, then bulbs 2 and 3, the circuit becomes a combination circuit. That means both series and parallel. Okay. That is called the combination circuit. The moment you close the switch, bulb 2 and bulb 3 are in parallel with, in series with bulb 1. Okay, here you see 2 and 3 are in parallel and in series with bulb 1. Okay, now our aim is to find out, after closing the switch, whether the bulb will be less brighter than the earlier one or bulb 2 will be less bright than the previous one. These are the 2 bits A and B, and we have to support with calculations. First, we have to give a qualitative explanation and then we have to prove it with a mathematical proof. Okay, we have to give the proof for that explanation. So for the first qualitative explanation, I give prediction, I will give the explanation. Suppose if you connect two resistors in parallel having the same resistance, the effective resistance will be R by 2. Here, both see that here the ease of the calculation is all the three bulbs are identical. Their resistances are same. Therefore, if two bulbs having the same resistance are connected in parallel, the effective resistance will be half the resistance. So R by 2 will be the resistance of this one. And if we connect this in series with another one, then the total resistance of the circuit will be less than the series one. These two are in series, and then the entire effective resistance for the combination circuit will be less than the series circuit. That you should know. I will prove that. And when the resistance is less, the current will be more. When the current is more, the bulb will be brighter. That is the answer for the first bit. Let us see how it will be. Whether I am right or not, we will see. Here, two resistors, two bulbs are in series. So the effective resistance will be 2R. Am I right? Okay. Now, what is the current flowing in the circuit? In this circuit, current is equal to V by R, Ohm's law. Here, I wrote the Ohm's law. Okay, see this one. This is the Ohm's law. Okay. This is Ohm's law. V is equal to IR is the Ohm's law. I is the current and V is the voltage and R is the load. Therefore, V is equal to IR or I is equal to V by R. According to this one, the current flowing in the circuit is equal to voltage divided by resistance. Voltage is E, and then the resistance just now we found out 2R. Therefore, the current is equal to E by 2R. So this much of current is flowing through the circuit. That means the current flowing through the bulb 1 is E by 2R, or 0.5 E by R. Okay. And because 1 and 2 are in series with each other, the same current flows through the second bulb also. Clear? So the switch is open now before closing the switch. Now we have to find out the effective resistance of the bulbs, all the three bulbs, soon after closing the switch. The moment you close the switch, these two bulbs will be in parallel with each other, and then the effective circuit will be in series with the bulb 1. See here, this is the parallel circuit, and this circuit is in series with the first one. Okay. Now we have to find out the effective resistance of bulb 2 and 3. So the effective resistance of the bulb 2 and 3 is R by 2. Here is the calculation. You can see R by 2. Now effective resistance of the entire circuit is 3 by 2 R. So this is the effective resistance we found out. Now we have to find out the current flowing in the circuit. Current flowing in the circuit is equal to voltage divided by resistance. Voltage is E, and then resistance is 3 by 2 R. Therefore, the current flowing in the circuit is 2E by 3R. Am I right? So 2E by 3R means 0.67 E by R. See the difference. Okay. So the current flowing through the circuit is this one. This is the current flowing through the circuit. So this is the current flowing through the bulb 1. And this is the current flowing through the bulb 1 before closing the switch. Which one is greater? This is greater. Am I right? This value is more than the first one. Obviously, as the more current flows through the bulb will be brighter. So it will not be the dimmer. So therefore, we disagree. Okay. So, but what he is saying is, he is asking us to prove with power. I proved with the current. Okay. Initially, I gave the qualitative explanation and then I confirmed my explanation with the numbers. Okay. But here he is asking us to derive an expression for the power expended by the bulb 1 after switch is closed. Before switch is closing, he gave it as P1, and we have to show that P2 is greater than P1 or P new. He gave a symbol P new. So P new is greater than P1. Then the bulb 1 will be brighter. So how it will be, we will see. We know power is equal to IV and V is equal to IR. Therefore, P is equal to I square R. In bulb 1, before closing the switch, P is equal to P1 is equal to, we know the current is equal to E by 2R. So E by 2R square times the resistance is R. Am I right? Here the resistance is R, and here also the resistance is R, and here also the resistance is R. Therefore, E by 2R square times R. Okay. Therefore, P1 is equal to E square by 4R. Agree? This is power before closing the switch. Now, power after closing the switch. What is the power? We know the current is equal to 2E by 3R after closing the switch. And then the resistance is R. Okay. So 2E by 3R square times R is equal to 4 by 9 E square over R. But we have to write this in terms of P1. So to make it in terms of P1, I am multiplying this equation with 4 and dividing the equation with 4 so that the value will not change. Now, you see, I have to take this into this form. So take out the 16 by 9 out. When you take out the 16 by 9 out, you are left with E square by 4R. So E square by 4R is P1. Therefore, P new is equal to 16 P1 by 9. And then 16 by 9 is 1.78. So P new is equal to 1.78 times P1. That means the power dissipated or power expended by bulb 1 after closing the switch is more than the power dissipated or power consumed. Am I right? What he's saying, power expended before closing the switch. Therefore, the bulb will be brighter compared to switch. The bulb 1 will be brighter after closing the switch compared to the switch open. Okay, that is the answer for this one. So we finished the first bit. Now we go for the second bit. What is the second bit? He is saying that the bulb 2 will be dimmer after closing the switch. That we'll see how it will be. Okay. See this one. Here, after closing the switch, this is the circuit. Am I right? And then for B2, the current, initially both the bulbs are in series, therefore the current flowing through the second bulb is also same as the first bulb, and therefore the current in the second bulb is equal to 0.5 E by R. Now current flowing the circuit after closing the switch is 2 by 3 E by R. This we already found now. Okay, now voltage drop at B1 is equal to current into resistance of B1. Okay, so this is the one. Am I right? Now, voltage at the junction, this is the junction. After leaving the current from the bulb, the current reaches the junction. So at this point, what is the voltage? The voltage will be remaining voltage. The original voltage minus the potential drop at B1 remaining this one. Okay, so we have to deduct this voltage drop at B1 and then the remaining will reach the junction. So E minus 2 by 3E is equal to E by 3. That is the voltage drop at the junction. Now we have to find out current through B2. Again, current is equal to voltage by resistance. So what is the voltage here? Voltage is E by 3 and then the resistance is R. Therefore, E by 3 divided by R is equal to E by 3R. R 0.3 E by R. Okay. So, the new current is less than the before one. Before it is 0.5 E by R. Now it is 0.3 E by R. which is less than this one. This value is less than this one. Am I right? This value is less than this one. No? So the brightness of bulb 2 will be less. So we are agreeing. Do you agree means yes. Okay. Next. What he is doing, the switch, he kept the switch open. No. Yeah, switch open. And then he replaced the bulb 3 with a capacitor, uncharged capacitor. Okay. When he is replacing the bulb with an uncharged capacitor and then closes the switch, then what happens? Uncharged capacitor means the resistance is 0. Resistance is 0 means voltage is 0 because V is equal to IR. Am I right? R is equal to, since R is equal to 0, V is equal to 0. When the voltage is 0 means what happens here? The bulb has the resistance. So the current will not flow to the second bulb. It flows through the capacitor. Okay. When it flows through the capacitor, the capacitor charges. Am I right? So what is happening here? The bulb B1 is brighter than B2 when we are attaching the uncharged capacitor. Am I right? We are attaching the uncharged capacitor and then closing the switch. Agree? When you attach a uncharged capacitor and close the switch, the entire current flows through the capacitor and the capacitor starts charging. Okay. So the bulb B1 is brighter than B2 because the current is not flowing through the B2. Agree? Next. Here, the next thing is after a long time, what happens to the brightness of the bulbs? After a long time, the capacitor gets fully charged. Once the capacitor gets fully charged, then it acts like an open switch. Current will no longer flows through the capacitor. The entire current flows through bulbs B1 and B2, and the circuit becomes a series circuit. See here. This is the one. Okay. So what happens? Both the bulbs will have the same brightness. Agree? So after a long time, the switch is closed. After closing the switch, if the capacitor starts charging, after a long time, the capacitor gets fully charged. Once the capacitor is fully charged, it acts like a open switch. So the entire current flows through the bulbs B1 and B2, and both will glow because they are in series with each other. They glow with the same brightness. That is the answer for this question. So if you know the Ohm's law and then combination circuits, how to calculate the current and voltage and power, then this question will be easy for you to answer. Hope this helps. Thank you. Bye-bye.